Alright, welcome to a lesson today on scientific notation. Now, scientific notation is a bit complex if we were to go deep into the details of why things are the way they are, but for this video we're not going to do that. In your chemistry class or your biology class you may go into that a bit more, but today's basically just kind of a refresher to say, hey, this is what you do, not why. So, the uses. We use scientific notation to make large or small numbers, I mean like small decimals, easier to see. So, a large number would look something like this. 2.34 times 10 to the 7th. And we know it's a large number because this 7 here is positive. So if you say positive exponent with your 10, then you know it's a large number. You know it's a small number, and by small I mean very small decimal, if you look at this number here and you see that it's a negative. So we have 3.42 times 10 to the negative 5th power. So that negative sign tells us that it is a small decimal. Okay, so now let's take it from standard form to scientific form with large numbers first. So here's what you're going to do on every single one of these, is identify where the decimal point is. So for number 1, we have 3,410,000. The decimal point, we don't see it, but it's right here at the 0. So first thing for any of these you do, whenever you're going standard to scientific, or scientific to standard, you identify where that decimal point is. So, specifically for our changing standard to scientific for large numbers, here's our decimal point. What we're now going to do is we're going to move our decimal point until it's right before our last number that is not a 0. So that would be that 3. Now what we're going to do is we're going to rewrite it with the decimal point just after the 3, so 3.41. But if there are any numbers that are 0 after a certain point, like here we have nothing but zeros left, we're not going to write those zeros. We don't need them. And again, you'll go more into that in your science class. You could spend multiple lessons on that, but just realize that now. So, we have our 3.41 times 10. And our times 10 is going to be to a power. That power we find by looking at how many times we moved our decimal point. So it looks like we moved our decimal point 1, 2, 3, 4, 5, 6. So we moved it 6 times, so it's 3.14 times 10 to the 6th. And now it's in scientific form. Okay. Number 2, our decimal point's right here. We're going to move it 1, 2, 3. So we get 1.25632. And we moved it 1, 2, 3 times, so times 10 to the 3rd. 3, our decimal point is at the end. 1, 2, 3, 4, 5, 6. And 2, 0, 3, 8. 0, 2, 7 times 10 to the 6th. Now this is different than the first one. You're probably thinking because, hey, there's a 0 here and there's a 0 here. The difference between number 1 and number 3 with these zeros is after this 0 right here, there's another number. Well, if there's another number, we need to keep that 0 between the 2 and the 3, so that we know it's just not the 2 and then the 3 if we were to transform it back into standard notation. Same thing here. we need that 0 there to separate this 8 and this 2. So that's why we have zeros in our scientific notation. Whereas for number 1, we don't have any numbers after this that the 0 needs to show us, that it's between, so we don't need it. That's the quick version of why there's zeros and why there's not. Okay, now we're going to go standard to scientific. So these are small, these are decimals. First thing, we identify the decimal point. It's right here, and then we're going to move it so that it is after the first number you get to. So we hit 3, we go past it. So 3.2 times 10, and this time it's going to be a negative exponent. So we moved it 1, 2, 3, so times 10 to the negative third. Number 2, 1, 2, 3, 4, 5, 4.028 times 10 to the negative fifth. 1, 2, 3, 4, 5 again, and we get 6.52 times 10 to the negative fifth. Now I am going kind of fast through these, so if you do not understand, please pause the video and ask. Okay, now we're going to go from scientific notation to standard notation. So this is a bit different. What I want you to do for this is, when you see the problem, rewrite the numbers that are on the left side, that are on the left of the multiplication symbol. So let's rewrite 5.46. Identify your decimal point, and then look at the 10 to the power. So it's 10 to the fourth. That means we're going to move our decimal point 4 times, either left or right. If the number is positive, we move it to the right. If the number is negative, we move it to the left. So I have 10 to the fourth, so I'm going to move this 4 times to the right. So 1, 2, 3, 4, decimal point. Now you see we have these gaps here. Well, we need to fill in those gaps. We're going to fill those gaps in with zeros. So that's where our zeros disappeared to for the standard to scientific. So we rewrite that as 54600, and we get 54,600. Now if you were to go backwards and go from standard to scientific, you'd get this. Okay. 2, 3.0704, and it's 10 to the third, so 1, 2, 3, and this is 3070.4. That was a bad 9. 9.21. Move it 8. 1, 2, 3, 4, 5, 6, 7, 8. And fill in a bunch of zeros. So 1, 2, 3, 1, 2, 3. There we go. Okay, scientific to standard for the small. Now this is going to work very similar to our large, except we're going to be moving our decimal point to the left. So 2.001, and I need to probably give myself some more room. So 2.001 to the fifth, 1, 2, 3, 4, 5, decimal point, zeros, fill in. Okay, I'm going to go ahead and go through and do these next two, so I suggest you pause the video and try to do them, because when you restart the video, the answers for 2 and 3 are going to be there. Okay, here are the solution to those. Count your zeros, see if you got it right. And finally, we're going to talk about operations with scientific notation, mainly talking about when we're multiplying. So, we have 2.21 times 10 to the third multiplied with 3.46 times 10 to the seventh. Here's what you need to do in order to get these right. Identify the numbers that are not with the times 10, so our 2.21 and our 3.46. And we're going to pull those out and separate them. So in one parenthesis, we're going to go 2.21 times 3.46. Then in the other bracket, we're going to do 10 to the third times 10 to the seventh. Then we're going to treat each one separately. So we do 2.21 times 3.46. We get 7.6466. And then 10 to the third times 10 to the seventh. Well, that's using our exponent properties. Our base is 10, so we get 10 to the 3 plus 7, which is 10 to the 10th. Now we're going to put it back together. 7.6466 times 10 to the 10th. There we go. So again, this was a long video. Sorry about that. And it was kind of went through things fast because there's a lot of information. So if you have questions, make sure you ask.